Welcome to the Topographic Maps video with Mrs. Lehnert at HSHM. By the end of this video, students will be able to describe how topographic maps show the shape of the land, and you should be able to interpret a topographic map. So we're going to kind of go on a little trip just for a little bit here. A couple of places we're going to visit, the Badlands in North Dakota. That's the picture in the left there. That's me on our little trip a few summers ago out to North Dakota. And then on the right-hand side, we're going to go to Devil's Tower, Wyoming. That's my husband and our car that we no longer have. And then there's a tall tower in the background there. That's actually the remnants of a very old volcano. And so that's like the inner core of the volcano that's left. All of the rest of the volcano has eroded away. It's gone away. The weather and the rain and everything kind of washed away the rest of the volcano. So we're going to go to these two places together, virtually, of course. First, let's visit the Badlands in North Dakota. That was the picture that was on the left there. And this is a topographic map of that area. And hopefully you can see that there is water right here. Water is always represented by blue on a topographic map. This is a little stream or a river that's flowing through this area. And the other thing that I hope that you notice is the thing that is at the very bottom of the map down here, which is a map scale. This is really helpful so that you know if you're looking at a really large area or a really tiny area on a map. Another thing hopefully you noticed is that there are numbers all along the edges of the map. Some of these numbers are helpful to us and some of them aren't, so the ones that are really helpful are these right here. These are latitude and longitude numbers, and they're usually in all four corners of the map. And finally, I'm sure that you noticed right away all of those brown little squiggly lines that are all over the map. These are really the most important part of a topographic map, and we're going to talk about those today. They are called contour lines, and if you've ever heard of contour makeup, it's kind of the same thing. It highlights where places are really high, like your cheekbones, for example, or where places are really low on a map or on a location on the planet. And here's another map. This is the one from Devil's Tower in Wyoming, that old leftover volcano. And you can see here's the tower right here in Wyoming. And you can see there are a lot of those brown contour lines right there. And they kind of form little circles. Anytime you see circles like that on a map, it's a hill, right? The tower is a really, really tall hill. All right, here's your first check for understanding. What can be seen on a topographic map? Can you see contour lines? Can you see water features? Can you see pictures of the area? Or can you see latitude and longitude coordinates? Select all of the ones that are possible. There's more than one that is correct for this question, so select all of them that apply. Okay, hopefully you got that right. It should have been contour lines. Remember, those were the brown squiggly lines. Water features, which is anything that's blue on the map, like the rivers and the lakes. And latitude and longitude coordinates. Those were the numbers that were in the corners. You'd never see actual pictures on a topographic map. Okay, let's keep going. So now that you've seen a couple of different topographic maps, we should probably talk about and define what a topographic map is. So a topographic map is a map that shows the topography of an area. Then I guess we need to know what this word is right here, topography. So topography just means the shape of the land. Is it really hilly or is it really flat? For example, on this block diagram on the right, there are a lot of valleys and a lot of hills. Right here, you can see that there is a valley and there's a river that runs right through the middle of that valley. And over in the upper left part of that block diagram, there are a lot of hills. Here's a hill, and here's a kind of a ridge of a hill. Here's a big tall hill. It's almost like these are mountain ranges, right? Like a series of mountains all stuck together. That's the shape of the land. That's the topography. And a topographic map, like the one on the left, shows that topography by using contour lines, which again are all of these brown squiggly lines that you see all over the map. And a map is a flat model of part of the Earth's surface that you can see from above. So it's a flat object, right? A two-dimensional thing that's trying to show us a three-dimensional object. The surface of the Earth has 3 dimensions, right? And we're looking at it from above. It's like you were a bird and you're flying overhead, and that's what you see on the map. Those little squiggly brown lines on those topographic maps show us something called elevation. Elevation is the height above sea level of a particular point on Earth's surface. So if the ocean is here, the top of the ocean would be sea level. And it's essentially where the ground and the ocean meet. So if you are here, you're at sea level. And then the elevation of something is how high above sea level that would be. So if you're at the top of this mountain right here, your elevation would be how many feet or how many meters you are above the level of the ocean. Another thing you see on a topographic map is a scale. The scale tells you the relationship, or in other words, it relates the distance on a map to a distance on Earth's surface. For example, on this picture, this is a scale, and this might not be that far of a different distance on the map. Maybe this is about, I don't know, about an inch on a map, like if you actually looked at the map that it was on. But in real life, this is a kilometer. A kilometer is about a half a mile. This is really helpful if you know you want to walk between 2 points on a map and you want to know, is this a really long distance or is it a really short distance? So those contour lines, these contour lines are these little brown lines, all of these little squiggly lines that you can see on a topographic map. And normally you don't see those on like a regular road map or a Google map, right? These lines show us the elevation. These are lines that connect points of equal elevation. So for example, if I'm standing here on that dark brown line, I'm going to be at the same exact elevation, the height above sea level, as I would be if I were here on that same line. As long as I'm on that same line, then I'm at the same elevation above sea level. And I think about these contour lines like we think about with makeup and how you use contour makeup to highlight different parts of your face. Girls will probably know this a little bit more maybe than boys do, but maybe boys know this too. You highlight, or if you want things to show up higher on your face, you would highlight them in a lighter color. Like this lady on the right hand side here, her cheekbones, she wants them to look higher, so she gives them a lighter color. And the things that she wants to kind of fade into the background, then she makes those a darker color. And so we call that contouring, because what you're trying to show is you're trying to show those high points of the face and the lower points of the face, just like you're trying to show elevation on a map, the high points of a map and the low points of a map. Topographic maps will often tell you what the contour interval is. A contour interval is the change in elevation from one contour line to another. I think of an interval as between things. In fact, the root word inter means between. On this map, they tell you the contour interval is 500, right here at the bottom. CI equals 500. For example, if the elevation of this contour line here, and let's say I'm here at point A, let's say that contour line is 3,500 feet because it's labeled 3,500. And this line here is 4,000 feet. So if I'm at point B, my elevation is 4,000 feet. As I go from A to B, I'm going to change elevation by 500 feet because 4,000 minus 3,500 is 500. And so that is the contour interval. A lot of maps will also have index contours. An index contour is a darker line that sometimes it's labeled with its elevation, but not all the time. So for example, on this map, the 100-foot index contour is labeled with the elevation. The 150-foot contour line index contour is not. And then the 200 index contour is labeled again with its elevation. So these are darker lines that you can see are much darker than those other contour lines. You can tell that it just makes it a little bit easier if there are a lot of contour lines all in one area to be able to tell which ones have numbers and to be able to distinguish them from each other. All right, time for another check your understanding. What is the contour interval of this map? It'll show up on the next slide. You're going to have to figure it out. They don't tell you, so look at it carefully, and yes, there is a correct answer. Okay, hopefully you got that and you figured out that the contour interval was 20 meters on that map. So now that you know that, what is the elevation of the contour line that is labeled XA? Okay, hopefully you got those all right, and even if you didn't, as long as you understand them, that's the important part. All right, so next up, we're going to talk about 7 different rules for contour lines. So number 1, all points along the same contour line are at the same elevation. Number 2, all contour lines eventually connect with themselves. So on this map, it kind of looks like those contour lines just end right at the edge of the map. But remember, we've zoomed way in on this picture of this little mountain that's here, right? We've zoomed way in on this topographic map. So if we could zoom out, if this is actually the map that is here in the picture, if we could zoom back out, we would see all of these other contour lines that are extending from that point where they ended at the edge of that map. Number 3, contour lines never cross one another. So you'll never see a map where 2 contour lines cross like that. This will never happen. So number 4, contour lines never split or branch. So if you are going along in your contour line and it's going along this way, you'll never see another one split off from that location. Okay. Number 5, contour lines bend or point uphill when they are crossing a stream. This is so cool. Let me show you an example of this. Here is Moose River flowing along. Now, I can tell by looking at this map that Moose River is flowing in this direction. So if I were to put a canoe in here and I wanted to flow downhill, I'm going to have to put it in right here at point A, and it's going to go flowing downhill, and I'm going to go down the stream all the way down here to point B. I know that because when I look at this particular map, there are contour lines that are crossing the stream. And as they cross Moose River, I'm calling it a stream, Moose River, they're bending. The direction that those contour lines bend or point is upstream or uphill. So if you look here, they're pointing, right? They're almost like making a little arrow, but they are pointing in the uphill direction. Every time you're looking at these maps, the direction that those contour lines are pointing is opposite of the direction that the river itself is flowing. Number 6, the highest elevation for a hill is always going to be one less than what the next contour line should be. So on this map, or on this, I guess, picture, this very top contour line is 80. The one below that is 70. So they're going up by tens. So the next contour line should be 90. But is there another contour line there? No. So the next contour line should be 90. So therefore the highest elevation is one less than whatever that should be. Since 90 is the contour line that should be next, it's 90 minus 1, which gives you 89.
And the last one, number 7. Sinkholes or craters are shown by dashed lines, or sometimes they'll call them hatcher marks. So you can see that on this map, this is a contour line, but it looks a little bit different than, say, this contour line right here. And that's because it has these little hatcher marks, these little dashed lines. These are telling you that this is not a hill. These are sinkholes or craters or holes in the ground. And these are a little bit different than this over here, which we see anytime you see these lines that are little circles without those little dash lines. This would be a hill. So it's the opposite of a sinkhole or a crater. And the elevation of the very first hatch mark to the very first hatcher mark or first line is always going to be equal to the lowest regular contour line nearby. So for example, this first one right here, let's say this is 100, and this one here, that means this one is also going to be 100. They're just going to repeat themselves.
Okay, just a few more questions. Time to check your understanding. Make sure you're using your notes to answer these questions.